Hello students, good morning. My name is Dr. Mallikarjun. Currently I am working in Institute of Aeronautical Engineering, Department of Information Technology. In the videos of lectures we are taking from the course of operating systems, today we are going to discuss about the first come, first serve scheduling. In the process as being executing in the CPU, there are many number of processes are executing. So that first come first serve scheduling is an algorithm how the process is executing. By first process comes the first that will chance to executing in the CPU. This is the first algorithm. So in the process scheduling algorithms, first come first serve scheduling comes as a preemptive scheduling. This is the preemptive. Means this is the different category scheduling, preemptive and non-preemptive scheduling. Preemptive is that the operating system can interrupt a preempt or running process to allocate CPU time to another process, typically based on priority or time sharing policies. Mainly process is switching from the running state to ready state. The process either it can be executing in the running state or ready state. So the process can be switched from ready state to running state, preemptive. Again running state you can switch, can waiting state. Preempt means they give the chance to another process. Suppose process P1 is in running state, which can be switched means it cancel, that process is going to be wait state. So they can other chance to process P2 come for the execution. Preemptive means that it can interrupt of the process P1, give the chance to the next process for the execution. So these algorithms of round robin, shortest remaining time fast, preemptive version of priority scheduling. So many are comes under preemptive scheduling. Coming to non-preemptive scheduling means that a running process cannot be interrupted by the other process system. It voluntarily relinquishes control of CPU. In the scheduling, once the resource CPU cycles are allocated to a process, the process holds the CPU till it gets terminated or reaches a waiting state. Algorithms based on non-preemptive scheduling are first come first serve, shortest job fast. The priority or non-preemptive versions comes under non-preemptive scheduling. So the process is in ready state or running state or waiting state. Suppose the process once submitted to CPU running state P1, it can't disturb until completion of the P1. So if completed, P1 is entirely completed, then give the chance to process P2 after completion of entire P1. This is non-preemptive fashion. Let me take consider one problem under this first come first serve scheduling. Let me take process number either 1, 2, 3, 4, 5. There are 5 processes are there. There are 5 processes. Their arrival times are 0, 1, 2, 3, 4. Their arrival times are 0, 1, 2, 3, 4. Their burst time means 4, 3, 1, 2, 5. Burst time means that is execution time. The process coming to execute that can be decided by the burst time. Now we have to solve this problem and calculate the average waiting time. Average waiting time you should calculate. So we have to draw the Gantt chart. So this problem comes under the non-preemptive fashion. This problem scheduling the given in the problem, this problem is non-preemptive fashion. So this is a non-preemptive means once process submit to the CPU, it can complete the total executing time, then next process can submit to the CPU. That process completing the entire execution, the next process is submit CPU. Means that non-preemptive fashion. So to solve this problem, we draw the Gantt chart first. Gantt chart. So Gantt chart is the one to decide which process is going to be executed next. So that can be drawn by using this Gantt chart. See, first at arrival time 0, first arrival time 0, process 1, first process 1 coming to the CPU and then starts the execution. Process 1. So at arrival time 0, process 1 came for the CPU and execution. It takes the 4 units of time for the execution. 4. Once it takes 4 units of time, the process P1 is completed. The arrival time is 4, means P2 is arrived, P3 is arrived at the interval of time 2 units of time. P3, P4 is also arrived at 3 units of arrival time. P5 is also arrived in the CPU at 4 units of time. All processes are arrived into CPU. So at 4 units of time, then got the chance P2 for the execution. So P2 burst time is 3 units of time. P2 burst time is 3 units of time. So P2 completed the execution at 7 units of time. So P2 completed their execution at 7 units of time. So next first come first serve basis. Next process P3 got the chance for the execution. P3. So P3 entered into CPU. Then it got 1 unit of time for the execution. So it takes 7 plus 1, 8. P3 completed at 8th unit of time. P3 is completed. So next first come first serve basis means that P4 entered into CPU. Then P4 coming to CPU and it takes 2 units of time for the completion. It takes 10 units of time. P4 is completed. Then finally last process P5 coming to the CPU and executed 5 units of time. It completed 15th interval of time. P5 is completed. Now at 15th interval of time, all processes are completed. So this is the final Gantt chart. So now we have to calculate the completion time. So completion time is very important. So what is completion time? Completion time. See, arrival time is when a process enters in the ready queue. That is the arrival time. Burst time is the time a process need to execute on CPU. That is the burst time. Now we are calculating the completion time. Is the when a process finishes its execution. So that is the completion time. Here, when a process finishes for the execution time, that is the completion time. Completion time is CT. Completion time is CT. This is CT. Burst time is BT. Arrival time is AT. Waiting time is WT. Turnaround time is TAT. That is the short words we use to write this problem. So here we are writing the completion time. So completion time P1 completed at 4 units of time. Then P2 completed at 7 units of time. P3 completed at 8 units of time. So P4 completed at 10 units of time. P5 completed at 15 units of time. So we are written completion times for all process. Completion time, burst time. Next we are calculating the turnaround time. Turnaround time is calculating the completion time minus arrival time. So turnaround time is completion time minus arrival time. Subtract here subtract the completion time minus arrival time. That is 4 minus 0, process P1, turnaround time is 4. 7 minus 1, the turnaround time is 6. 8 minus 2, the turnaround time is 6. 10 minus 3, the turnaround time is 7. 15 minus 4, the turnaround time is 11. So, this is the turnaround time. So, what is turnaround time? Turnaround time is the total time from arrival to completion. So, this is the very important. Turnaround time is the total time from arrival to completion that you calculated turnaround time. So, this is the formula for turnaround time. Turnaround time is equal to completion time minus arrival time. Then, we calculate the waiting time. So, how to calculate waiting time? So, there is a formula for waiting time. Waiting time is equal to turnaround time minus burst time. Waiting time, we should calculate turnaround time minus burst time. So what is waiting time? Let me see that waiting time is the time a process spends waiting in the ready queue that you calculate. So waiting time here, turnaround time minus burst time, or also we can also represent like that. Turnaround time is equal to waiting time plus burst time. We can write like this also. Waiting time is equal to turnaround time minus burst time, or turnaround time is equal to waiting time plus burst time. So we calculate that waiting time, turnaround time minus burst time. This subtract from this. So 4 minus 4, 0, 6 minus 3, 6 minus 3, 3, 6 minus 1, 5, 7 minus 2, 5, 11 minus 5, 6. So now we have to calculate the final question, calculate the average waiting time. So average waiting time is add all these things, 0 plus 3 plus 5 plus 5 plus 6 by total number of processes are 5, 1 to 5. So this is 10 plus 6, 16 plus 3, 19 by 5. So that is final 3.4 something, we can get the average waiting time. So final solution for this average waiting time is 3.4. We calculate this problem. This problem executed under non-preemptive scheduling and calculate the average waiting time. So we calculated waiting time, turnaround time, burst time, completion time, arrival time, all I mentioned here. Arrival time is when a process enters this ready queue. Burst time is the time a process need to execute on the CPU. Completion time is when a process finishes its execution. Waiting time is the time the process spends waiting in the ready queue. Turnaround time is the total time from arrival to completion. So this problem we calculated as the average waiting time 3.4 when the process P1 to P5, where arrival times are 0, 1, 2, 3, 4, their burst times are 4, 3, 1, 2, 5, then we calculated the average waiting time. Okay, students. So these problems, we've seen many problems in the books of Abraham Silberscrabs, Galvin book in the title of Operating Systems Principles and Wiley Student Edition. And also we referred these problems, William Stallings, Operating Systems, Internal Design Principles, Pearson Education, 6th edition, 2002. We calculated today first come first serve scheduling in the scheduling process scheduling in the series of lectures of operating system. Thank you, students. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.